Hey, we're back looking at the sum of an arithmetic sequence. I'm on page 15, number 12. Dan is also training for the half marathon. On the first day, he runs 0.15 kilometers, the second day, 2.9, and on the third day, he runs 5.65 kilometers. If Dan continues increasing his distance by the same amount every day, will he have run more than Jemima by the end of day 20? All right, this refers back to problem 11, which we did in the previous video. What her total was after day 20 was 440 kilometers. So you're going to need to know that in order to compare your total for Dan to that total for Jemima. So now we've got some new variables here. We've got on the first day he runs 0.15, so that's our new A, which is the first term in the sequence. And let's see, we've got a new D as well. If it goes from 0.15 to 2.9, we've got to look at the difference between those. It increased by 2.75, so that's our new D. Our N is holding steady at 20. So we're ready to plug these three things into our formula right here. Sum of an arithmetic sequence. So here we go. Sum of 20 equals 20 over 2, that's just 10. Let's go ahead and write that in. And then we've got 2 times A, so that's 2 times 0.15. And then it's plus D, which is 2.75. And then 20 minus 1, which let's just call that 19. So we're just going to make sure to be careful with our order of operations here and do these multiplications before we add them together. So 2 times 0.15 is 0.3, and 2.75 times 19, that's going to give us 52.25. Are you with me so far? If not, I hope you pause the video and get caught up. In the meantime, we've got 10 times 52.55. So our last step, which is the sum through 20 terms or 20 days of running, is 10 times 52.55. Look, just move that decimal one to the right. 525.5 kilometers. So the question is, will he have run more than Jemima by the end of day 20? So he's run 525.5. She ran 440. So the answer is yes. And there we have part A. Now, moving on to part B. On what day will Jemima and Dan be running a similar distance? Well, let's see. The easiest way to do that in this case is just to find the next terms in the sequence and compare their differences. There is an algebraic way, but that is more complicated. Wouldn't you like the simpler way? I think you do. So we're going to look at Jemima here, Dan here, and then we're going to look at the difference here, because they want to know the day when they're running a similar distance. So when this difference column gets to its lowest value, that's the day we're looking for. So we don't know when this is going to be. Let's try a few and see what we come up with. 5, 6, 7, 8. Jemima, you may recall, this was back in problem 11. She started at 3, and she went up 2 every day. So it went 3, 5, 7, 9, 11, 13, 15, and 17. Now Dan is starting at 0.15 and going up by 2.75 each day. So that takes it to 2.9. All right, let's start doing these differences here while we're going around so we can see the trend. They're going to be farther apart, but Dan's going to be closing on Jemima, and we want to know when they're as close as possible together. So 3 minus 0.15, that's 2.85. 5 minus 2.9, that's 2.1, getting closer. So if we increase that 2.9 by 2.75, that gives us 565. And then if we do 7 minus 5.65, we get 1.35. Getting closer. On day 4, we're going to add 2.75 again. That gives us 8.4. Now there's only 0.6 difference between them. Day 5, adding 2.75 here gives us 11.15. That's just a difference of 0.15. Closer even still. How about day 6? Well, we're going to add the 2.75. That gives us 13.9, which we can see now the difference is going back up. It's back to 0.9. So it's only going to, this difference here is only going to keep getting larger. So we don't really need to do these, do we? We can just be confident that the day we're looking for is right here, day 5, when they both run pretty close to 11 kilometers that day. So our answer here, on what day will Jemima and Dan be running a similar distance? Day 5. All right, thanks for watching, everybody. Hope to see you soon.